Welcome. Today we're going to talk about our final project, which is Logistic Regression Study in a Call Center. We are the team, the Tigers, which is formed by Pietro Gianelli, Eduardo Huiza, Daniel Muriano, y Nicolas Rodriguez. First part, project background. First, we will utilize logistic regression to know which variables affect a client satisfaction in his or her experience after calling for a travel call center. Since it is a call center, the calls are international, therefore there are many clients which have many languages. The dates are also included and their corresponding times in the world, as well as the call duration. Also, not all calls have all data that should be registered per call, so we have missing data. The data will be relevant when the rating is from 1 to 5 because blanks and zeros means that the client did not take the survey. Hypotheses. We will be stating 3 hypotheses. The first one is regarding the time or the duration of the call. If the call is transferred, it will affect negatively the client satisfaction as this causes a certain discomfort as the call gets longer. Nobody really wants to wait that long. Therefore, as the call gets longer, the satisfaction lowers. Next one is the client's experience gained in level 2 is affected by the client's experience gained in level 1. If the first experience is bad, then the whole rating will be bad because of prospect theory. Negative experience affects more than a positive one. If the skills required by the client are met or exceeded by the worker, then the rating will be good. Project variables and assumptions. The dependent variable y will be rating. A good rating will be a 1 in logistic regression, but in the data is a 4 or a 5, which means the client is satisfied. A bad rating, which means in logistic regression is a 0, will be a 1, 2, or 3 in the data, which means the client is not satisfied. The independent variables will be like skills, duration, etc. Then, when people are neutral about the service, they will tend to ignore the survey, so there will be many non-responsive spaces. People will answer the survey with extremes, 1 or 5, so logistic regression is used correctly.
Diagnostics. First, we have to check the data. We have to describe it by checking basically for multicollinearity, linearity assumption, and outliers. The first problem is multicollinearity. We check that using the alias function for the models. Multicollinearity is present when you have two variables that are highly correlated, and it is a problem because you don't know how much is the effect of one variable against the other. In this case, we saw some NAs in the first model. That also means that exists multicollinearity because using alias function, the correlation between those variables was 1, so the solution was to meet them. Those variables were language skill required Portuguese, language Portuguese, and customer loyalty category 5. Then we check for linearity assumption. In our ordinary regression, we assume that the outcome had linear relationship with the predictors. In logistic regression, the outcome is categorical, and so this assumption is violated. That's why we use the logic of the data to check this. But there was not a clear linearity between the dependent and independent variables as you can see in the graphics. And finally, we check for outliers using the Cook function. There was only one outlier which is a good for the model. This might be because of external factors like a typing error, for example.
As you know, we are going to create models to predict what will be the output of that dependent variable, that in this case is the rating of the call center. So basically, we're going to create models to see what independent variables are more significant to predict the dependent variable. Okay, so we make our first model that use all the independent variables excepting the dates. No, and we can see that a few of them are really significant, like the classified service or the loyalty skill, for example. No, but also we can see that there are a lot of NAs in the model. This means that these that it, that these variables that have the NAs have multicollinearity with other variables. So this first model is to see what variables have multicollinearity with other variables. So we are going to remove these variables and we have the next model. So we have this model and we can see that the area under the curve is the same. So removing these variables is a good step, no? But we cannot see a lot of change, so we are going to remove some insignificant variables, no? And we are going to see the results in the next model. Okay, now with that we have an area under the curve less than the previous model because we remove some insignificant variables. But also we gain that this model is simpler than the previous model. So what will be the next step to improve more this model? So as you know, this model is created with a training data and it is tested with a testing data. So we are going to mix more this data and we have the next result. Okay, so if we mix data, we can see that we have a better area under the curve. So why this happens? Because we are using the same data. So this happens basically because this model was made with the training data. So if we mix this data with I don't know randomly, this means that the data have more inputs, have more variety in the data to make better predicts. So this is why the model improve in the area. So we are going to make this model simpler to to satisfy the parsimony's law. Okay, so finally we have the parsimony model that basically have an area under the curve of 0.58, and we can see, and this is really interesting, that we can see that all the independent variables are significant. So this means that we can explain the the rating of the call center with only these independent variables. And this part of the exposition can be seen with this slide that show us what were the models that we create and what will be the final model what we are going to work with.
Model interpretation. The first three models are actually the opposite of what we're trying to demonstrate with the dependent variable. This means that the rock curve under the curve is below 0.5. So this means these models are not trustworthy and the independent variables need to be intervened to improve them. The fourth model is actually the best one as it shows the biggest area among them, the area under the rock curve. This indicates that the model is trustworthy, but it's very complicated as it involves a lot of independent variables. So we go to the fifth model, which we called parsimony model. We call it parsimony model as the area under the curve is just 0.02 less than the fourth model, but it involves a lot less of independent variables, which is an improvement in simplicity. Actually, the parsimony theory explains that simplicity is good in a regression model. So in conclusion, we choose the parsimony model as the model of election because it gives out 0.02 in area for a great improvement in simplicity. This means that the model explains less, but it's much more manageable, which is good for people to understand the actual model. The hypotheses were right. The duration of the call was significant, but not in the extent of what we were proposing, as it was less significant than we thought. So, the duration of the call is actually significant, but the client doesn't care if the call was too long, as long as it resolved his or her problems. If the call was transferred, was not really significant, but instead we found out that if the call was classified by the agent, that means that the rating will be higher. So the classification of the call was very important, as this increases the rating of the model. The skills and language required by the client were very significant, as they affected the rating directly. So if the skills and language required by the client were actually the ones that the agent had, this means that the rating will increase. So in logistic regression, we will get a 1. Advice. According to the parsimony theory, it is better to choose a model which explains enough, but it is simpler, than a model that explains a bit more, but it is more complicated, more independent variables involved. So that's why we chose the parsimony model instead of the other 4 models, because it explains a bit less than the 4th model, but is much more simpler. It is better to clean up the data before actually proposing the model, as they will not explain enough, or even explain the opposite of what we're looking for. So in the first 3 models, the area under the rock curve was explaining that it was 0.5, it was below 0.5. So this actually was explaining the opposite of what we're trying to explain. So this is not trustworthy, and it is better to clean up the data and select the variables that we thought with the hypotheses that were important before actually proposing the models. There have to be a balanced data to create a model and test it. In this case, we observed that the 3rd model and the 4th model are different because of this. In the case of the last models, the data was more balanced. In other words, it had more variety of data. So we chose a training data according to the data of the Excel sheets, but when we chose a better training data where the data was randomized, this improved the model, as the 3rd model was not trustworthy and the 4th model was trustworthy. So a good takeover is that we should always randomize the data so that the software R will use the data in a better order. Another variable, like quantity of people available, will be of interest, as the capacity can explain if people wait until they get attended. Also, waiting time until being attended can be another good independent variable. When you call a call center and the agent keep you waiting for another agent to be free to attend you, that increases your unsatisfaction. So that will be a very good variable to have in mind for another experiment of this kind. Thank you very much for listening to our presentation. We'd like to highlight 3 important points of this assessment. First of all, it is a good practice to state a hypothesis. So we're trying to guess what we're going to find out with the models. Second point, it is always good to state the diagnostics, multicollinearity, linearity assumptions, and outliers, as they are very important for the model. And last but not least, we'll always like to share the parsimony theory, because a simpler model is better than a more complicated one that explains just a bit more. Thank you very much again, and that's all.